Tonight we begin a gentle journey into the luminous expanse of our galactic home, the Milky Way. As you settle into a calmer state, imagine the world around you dimming until only a faint glow remains. A glow that might come from a single star or from the collective shimmer of millions. Above us stretches a soft river of light, a celestial band arching across the sky, mysterious yet comforting, ancient yet ever-present. For thousands of years, people have looked upward and wondered about this glowing trail, weaving stories and myths to explain what they saw. Today, science reveals a different understanding, but not one devoid of poetry. The Milky Way is a vast barred spiral galaxy, its structure shaped by billions of stars, intricate gravitational patterns, and cosmic time itself. As we enter its quiet pathways, let your breath slow, your thoughts soften, and your imagination wander freely across its starlit horizons. This is not merely an astronomical exploration. It is a meditative voyage into a cosmic sanctuary. With each step we take, with each star we pass, we move deeper into the quiet rhythm of the universe. The galaxy envelops us like a gentle night tide, carrying us across arms of starlight, through clouds of dust, and into the heart of a structure far older than Earth. Let every description wash over you like a soft whisper from distant worlds, guiding your mind toward rest. Our journey begins now, at the threshold of understanding, as we drift slowly and peacefully into the luminous heart of the Milky Way. Before we drift farther into our galactic voyage, I invite you to support this sleepy science channel with a quiet and simple gesture. By subscribing, you help us move gently toward our first 1,000 dreamers. Listeners who, like you, seek knowledge wrapped in calmness, and who find comfort in journeys carried by starlight and slow storytelling. Your presence here already means more than you know, and each new subscriber helps keep these tranquil explorations alive. If this soothing way of learning brings you peace, your support ensures that more journeys like this one continue to unfold, night after night. With every subscription, you help us craft new stories, explore new worlds, and deepen our cosmic wanderings together. Thank you for being part of this serene adventure. Imagine standing beneath a night sky, untouched by city lights, where darkness settles gently around you, and the stars shine with serene clarity. As your eyes adjust, a faint band of milky light stretches across the heavens, delicate and mysterious. This is the first glimpse of the Milky Way, as seen from Earth, a softly glowing trail formed by the combined radiance of countless stars too distant to distinguish individually. Ancient cultures saw this celestial river as sacred. The Greeks imagined it as milk spilled across the sky, the Romans as a divine roadway, and many indigenous peoples as a bridge for spirits or a map of ancestral journeys. Each interpretation wrapped the galaxy in meaning, transforming the night sky into a canvas of myth and wonder. Science paints a complementary picture. The Milky Way is a barred spiral galaxy about 100,000 light-years across, composed of swirling arms that wrap around a glowing central core. Our solar system lies within one of these arms, quietly orbiting the galactic center at immense speed, though we remain unaware of the motion. When you imagine yourself floating just outside the galaxy, the Milky Way becomes a shimmering disk, bright at the center and fading toward the edges, a cosmic lantern suspended in eternal night. This first look is merely an introduction, a soft invitation into the deeper mysteries and calming immensities that await within our galactic home. As we drift a little closer, the Milky Way's elegant structure becomes clearer, revealing itself as a magnificent barred spiral. At the center lies a bright, elongated bar of stars, a gravitational engine that guides the motion of surrounding material. This bar shapes the galaxy's dynamics, drawing gas and dust into patterns that ripple outward into sweeping spiral arms. These arms are not rigid structures, but gentle density waves, regions where stars cluster more tightly, giving the galaxy its iconic swirling appearance. From the central bar extend the great spiral arms, Sagittarius, Perseus, Scutum Centaurus, and our own modest Orion arm. Within them are vast clouds of hydrogen, stellar nurseries, where new stars are born in glowing clusters. If you could float through one of these regions, the scene would resemble drifting inside a luminous mist, slowly shifting and glowing with embryonic starlight. The galaxy rotates incredibly slowly on human timescales, but flows with unmistakable grace, carrying billions of stars on orbits, sculpted by gravity and time. Through this vastness, we quietly ride, observers drifting within a grand cosmic pattern. Now our attention turns to our more intimate cosmic neighborhood, the Orion Arm, also known as the Orion Spur. It is a small branch between the Milky Way's larger arms, not dense or dramatic, but peaceful, stable, and rich with the chemical ingredients needed for life. Our solar system resides within a region called the local bubble, a cavity of low-density gas carved long ago by ancient supernova explosions. To imagine it is to picture a vast, nearly invisible chamber in space through which the sun drifts quietly, carrying Earth along on its unhurried journey. The Orion Arm hosts familiar celestial landmarks, the glowing Orion Nebula, where stars ignite from clouds of gas, the Pleiades Cluster, a shimmering group of young hot stars, and the great arc of Barnard's Loop, a monumental curve of reddish gas. These structures form the scenery of our part of the galaxy, a stellar landscape we've grown to know through telescopes and stories. In this region, stars are born, live their luminous lives, and eventually fade, contributing their materials back to the interstellar medium. We, too, drift through this gentle suburb of the galaxy, part of an ongoing cosmic cycle far older than human memory. As we move onward, we enter interstellar space, the vast expanse between stars, often imagined as empty, but truly filled with a thin, delicate mixture of hydrogen atoms, dust grains, and faint molecular traces. If you could float here with perfect stillness, you would see grains of dust drifting like cosmic snowflakes, illuminated faintly by starlight from every direction. Now and then, a cold, dark molecular cloud would emerge from the void, enormous and shadowed, hiding the seeds of future stars within its dense interior. These clouds are the birthplaces of solar systems, glowing softly at their edges where ultraviolet light strikes their surfaces. Interstellar space holds the recycled remnants of ancient suns, atoms forged in explosions long before Earth existed. The quiet electromagnetic whispers of pulsars and the lingering afterglow of the Big Bang travel through this medium like distant echoes. Though silent to human ears, space vibrates with the low, eternal hum of cosmic history. Moving through this region is a reminder of the vastness separating stars, yet also of the deep connectivity shared across the galaxy. Everything here participates in a long, slow cycle of creation and transformation. And as you drift through this serene emptiness, your own thoughts may slow to match its tranquil pace. As we continue our journey, a small constellation of nearby stars comes into view, our immediate stellar neighbors. The closest is Proxima Centauri, a cool red dwarf, only 4.24 light-years away, hosting at least one planet that lies within its habitable zone. Alongside it orbit Alpha Centauri A and B, forming a triple-star system far more common than our solitary sun. These stars, though distant, form a kind of cosmic family around us, each moving with us as we travel around the galactic center. Other neighbors include Barnard's Star, one of the fastest moving stars in the sky, Wolf 359, dim and cool, and Sirius, the brightest star visible from Earth, shining with brilliant intensity. Together they reveal the diversity of stellar life across even a small patch of our galaxy. As you imagine drifting among them, you may feel surrounded by gentle beacons, each with its own story, its own planets, its own potential. They form a peaceful constellation of companions as we continue our serene voyage through the Milky Way. The Sun, though steady and familiar to us on Earth, is a traveler on an immense and ancient journey, an orbit around the center of the Milky Way that takes roughly 230 million years to complete. Astronomers call this vast cycle a galactic year, and our solar system has completed fewer than 20 of them since it first formed. As you imagine this pathway, picture the Sun not as a fixed anchor, but as a glowing vessel drifting through a cosmic river, pulling Earth and all its planets along in a slow, spiraling dance. The speed is astonishing, about 220 kilometers per second, yet the motion feels gentle, almost imperceptible, because space is so vast and distances so immense that the journey unfolds across eras longer than any human timescale. Throughout its orbit, the Sun moves through regions of varying density, clusters of stars, quiet pockets of interstellar gas, and the boundaries of the local bubble. These environments shape the solar wind and subtly influence cosmic rays reaching Earth. Over geological ages, this shifting environment may have played a role in climate changes, asteroid patterns, and even evolutionary pathways. And yet, despite the Sun's extraordinary speed and the vastness of its orbit, we experience none of it directly. We drift peacefully along with our star, passengers on its luminous voyage around the galaxy, unaware of the gravitational choreography unfolding on a scale too large for daily perception. As we continue inward on our conceptual journey, the Milky Way's core begins to glow like a distant hearth, bright and dense with stars. Though we are still tens of thousands of light years away, the galactic center reveals itself as a region of extraordinary activity. Stars crowd together by the millions, interstellar dust thickens into dark lanes, and gas clouds swirl in intricate patterns. If you could look directly toward the center, with perfect clarity, free of the dust that obscures our view from Earth, you would see an astonishing tapestry of brilliance, with stars so tightly packed that the night there would never be dark. Yet the core is not only a place of light, it is also shaped by a powerful gravitational force. Sagittarius A*, the supermassive black hole that anchors the galaxy. Though completely invisible, its presence can be traced by watching nearby stars whip around it in tight, rapid orbits, moving so fast that only an immense compact mass could produce such motion. From afar, the center feels like a quiet giant, holding the galaxy together with a steady gravitational hand. Even at our great distance, its influence reaches us, guiding the Sun's orbit and maintaining the structure of the Milky Way. To drift toward it, even imaginatively, is to sense the deep heartbeat of the galaxy. At the very heart of the Milky Way rests Sagittarius A, a supermassive black hole, about 4 million times the mass of our Sun. Despite its fearsome reputation, it is remarkably calm compared to black holes in more active galaxies. Rather than devouring stars in violent bursts, Sagittarius A spends most of its time in a state of quiet slumber, glowing faintly in radio waves as small amounts of gas fall inward. If you could hover safely at a great distance, you might see a soft, flickering halo of hot plasma surrounding it, swirling in spirals before disappearing into the event horizon. This black hole is not a destructive force, tearing the galaxy apart. Instead, it is a stabilizing presence, a gravitational anchor that helps maintain the Milky Way's structure across billions of years. The stars closest to it follow graceful, elliptical paths, completing an orbit in mere decades, astonishingly fast compared to the Sun's enormous galactic circuit. These stars act like celestial markers, revealing the black hole's mass and motion. And though the idea of such an object can seem intimidating, in the quiet context of the galaxy, Sagittarius A* feels more like a sleeping giant, holding the galactic core in a gentle gravitational embrace. Venturing conceptually closer to the galactic center, imagine entering a realm where stars crowd together with unimaginable density. In this region, known as the central bulge. There may be a million stars within a volume that near Earth would contain only a handful. The sky here would glow constantly, lit by countless suns of varying size, heat, and age. Some stars are ancient remnants left from the early days of the galaxy. Others burn hot and bright, newly formed from dense gas clouds stirred by gravity and radiation. The interstellar medium grows thicker too, forming elegant ribbons of dust that twist among the stars in shadowy lanes. Because the bulge is so dense, stellar encounters are more common, and the dynamics of the region are fast-paced compared to the quiet outskirts where the sun resides. Star clusters move in great swarms, gas clouds collide and compress, and gravitational waves ripple through the environment. Yet for all its busyness, the core radiates a profound and steady beauty. The concentration of light is so great that nighttime would never fall there. Instead, the sky would shimmer in perpetual starlight. It is a reminder that the Milky Way is not uniform, but filled with contrasting environments, some peaceful and sparse, others dazzling and crowded with cosmic activity. As our journey pauses at this midpoint, we turn our attention to something unseen yet essential: dark matter, the mysterious substance that forms the invisible scaffold of the Milky Way. Though it emits no light and interacts minimally with normal matter, its gravitational influence is unmistakable. Without dark matter, the galaxy's spiral arms would fly apart. Stars at the outer edges would drift away into intergalactic space. Instead, dark matter creates a vast halo around the Milky Way, a spherical structure extending far beyond the visible disk, holding everything in place. Scientists still do not know exactly what dark matter is, only that it outweighs normal matter by a significant margin and shapes the motion of stars throughout the galaxy. As we drift through the imagined paths of the Milky Way, dark matter acts like a quiet, unseen guide, gently shaping orbits and maintaining the galaxy's coherence across billions of years. It is a comforting presence in its own way, vast, mysterious, and essential. Though invisible, it is part of the gentle architecture that allows our galactic home to exist in the tranquil form we observe today. A reminder that not all truths of the universe must be visible to be real. The spiral arms of the Milky Way appear from afar like elegant swirls of light, but up close, they are living structures, shaped not by static lines of stars, but by waves of density, traveling slowly through the galactic disk. These waves act like gentle traffic jams in space. As gas and dust pass through them, they compress, triggering the birth of new stars and forming bright clusters that illuminate the arms. If you could drift alongside one of these waves, you would see stars forming in luminous pockets, glowing nebulae, unfolding like cosmic blossoms, and older stars emerging behind them as the wave continues onward. In this way, the spiral arms are not permanent structures, but dynamic, ever-moving regions that guide the rhythm of star formation throughout the galaxy. These arms also serve as highways for countless celestial travelers, from migrating star clusters to wandering rogue planets ejected from their birth systems. The Sun itself has crossed several spiral structures during its long galactic orbit, each passage subtly influencing the environment around Earth. Some scientists speculate that these crossings may correlate with changes in comet influx or interstellar cloud density, shifting the cosmic conditions in which life on Earth has evolved. Yet despite their grand scale and slow motion, spiral arms radiate a sense of harmony, rhythmic waves sculpting the galaxy into its iconic shape, an endless choreography unfolding across hundreds of millions of years. Nebulae, the glowing cradles of stars, are among the most breathtaking structures within the Milky Way, composed of hydrogen gas, dust, and complex molecules. These vast clouds serve as the birthplaces of suns, planets, and solar systems. Within them, turbulence and gravity collaborate in a slow, delicate dance. Regions of gas collapse inward, heating as they compress, until the pressure becomes great enough to ignite nuclear fusion. A newborn star emerges in brilliance, pushing back the surrounding cloud with its radiation and sculpting the nebula into intricate shapes. If you could float within such a nursery, the view would be ethereal, ribbons of violet and red gas flowing around you, illuminated by clusters of young stars shining through the mist. Some nebulae, like the Orion Nebula or the Eagle Nebula's pillars of creation, are iconic examples of star birth captured in stunning detail by our telescopes. Others remain hidden behind thick curtains of dust, visible only through infrared or radio observations. These regions not only produce stars, but also create the raw materials for planets, comets, and perhaps even the molecules necessary for life. Every atom of carbon, oxygen, and iron that forms our bodies was once forged inside stars or distributed by supernovae into clouds like these. To wander through a nebula, even in imagination, is to witness the earliest stages of cosmic life, slow, quiet processes that shape everything we know. Every star in the Milky Way follows a long and predictable journey, shaped by its mass and composition. A star begins in a nebula, glowing faintly, as gravitational collapse turns dust and gas into a compact heating sphere. When temperatures at its core become high enough to fuse hydrogen into helium, it enters what astronomers call the main sequence, the long, stable phase of a star's life. Our Sun is currently in this stage, shining steadily as it converts hydrogen into energy. More massive stars burn brighter and faster, while smaller ones glow gently for trillions of years. This diversity forms a stellar symphony, each star moving through its life according to an elegant internal clock. Eventually, stars exhaust their hydrogen fuel and begin to change dramatically. Medium-sized stars like the Sun swell into red giants, shedding their outer layers to create planetary nebulae, delicate shells of light that drift across space like cosmic lanterns. Their cores contract into white dwarfs, small and faint, but incredibly dense. Larger stars end their lives more violently, collapsing and exploding in brilliant supernovae that scatter heavy elements across the galaxy. These remnants enrich interstellar clouds, seeding future generations of stars and planets. In this cycle, no star truly disappears. Its materials continue their journey, merging into new worlds and new suns. Stellar evolution is thus not a single story, but a grand weaving of lives, endings, and beginnings across billions of years. Supernovae are among the most powerful events in the universe, yet they play a gentle and essential role in shaping the Milky Way. When a massive star reaches the end of its life, its core collapses under its own weight, triggering an explosion so bright it can momentarily outshine an entire galaxy. These cataclysms release shock waves that sweep through nearby gas clouds, compressing them and often triggering the birth of new stars. In this way, the death of one star becomes the beginning of many others, continuing the cycle of stellar creation. But the significance of supernovae goes even deeper. They are responsible for forging nearly all heavy elements in the universe, including the iron in our blood and the calcium in our bones. The remnants of supernovae form spectacular structures, expanding clouds of glowing gas like the Crab Nebula or the Veil Nebula, each revealing the turbulent aftermath of stellar death. These remnants can spread across light years, their filaments weaving through interstellar space as they cool and disperse. Hidden within them may be neutron stars, ultra-dense objects spinning rapidly and emitting strong magnetic fields, or even the seeds of future black holes. Though supernovae are rare in any one region, their influence is immense, enriching the galaxy and shaping the conditions for life. The Milky Way's beauty, diversity, and chemical richness owe much to these brilliant transformative events. Not all worlds in the Milky Way orbit stars. Some planets drift through interstellar space alone, unbound to any sun, wandering in eternal night. These are rogue planets, formed either in solar systems where gravitational interactions flung them outward, or in isolation within collapsing clouds that never ignited into stars. If you could approach one of these worlds, you would find a cold, dark sphere illuminated only by the faint glow of distant starlight, or the weak heat lingering in its core. Without a parent star, their atmospheres, if they have any, would be frigid and still, shaped only by internal processes and cosmic radiation. Though they may seem lonely, rogue planets offer fascinating possibilities. Some may harbor subsurface oceans, heated by tidal friction or radioactive decay, creating environments that could sustain primitive forms of life. Others carry clues about the early dynamics of planetary systems or the violent gravitational interactions that scatter worlds into the galactic void. Invisible to the naked eye and difficult to detect, even with advanced instruments, rogue planets drift silently between the stars, contributing to the hidden population of the galaxy. Their existence reminds us that the Milky Way is full not only of bright, obvious structures, but also of quiet travelers moving through the dark in peaceful solitude. Globular clusters are among the oldest structures in the Milky Way, vast spherical gatherings of hundreds of thousands of stars tightly bound by gravity. If you could drift into one of these clusters, you would find a sky so dense with starlight that darkness barely exists. Brilliant suns would fill every corner of your view, shining in golden and blue hues. These stellar metropolises orbit the galaxy's halo, far above and below the galactic plane, like ancient guardians watching over the Milky Way from lofty, quiet distances. Most of the stars within them are extraordinarily old, some more than 12 billion years, making them cosmic fossils that preserve the earliest chapters of our galaxy's history. Their arrangement is orderly and precise, shaped by gravitational interactions that have played out over epochs longer than human imagination. Despite their massive populations, globular clusters are surprisingly tranquil. Stars move in slow, graceful orbits, rarely colliding, thanks to the vast distances between them. Even in such a densely packed environment, scientists study these clusters not only to understand stellar evolution, but also to trace the formation of the Milky Way itself. Their ages reveal when the galaxy first began assembling, and their distribution hints at past mergers with other galaxies. To imagine drifting among them is to travel through time, surrounded by suns that have burned steadily since near the dawn of the universe. These clusters embody endurance and cosmic memory, holding luminous stories from eras long before Earth formed. Encircling the Milky Way like a faint, invisible cocoon is the galactic halo, a vast spherical region composed of thin gas, ancient stars, dark matter, and globular clusters scattered like distant lanterns. Unlike the bright, structured disk of the galaxy, the halo is diffuse and ghostly, stretching far beyond the visible boundaries of the Milky Way. If you drifted into this realm, you would find space even quieter than the interstellar medium within the disk. Matter becomes sparse, starlight grows faint, and the sensations of motion and place begin to dissolve. Yet hidden within this emptiness are clues to the galaxy's earliest formation. Faint dwarf galaxies, torn apart by gravity, streams of stars from long-consumed companions, and pockets of gas that have remained undisturbed for billions of years. The halo also hosts the vast reservoir of dark matter that envelops the galaxy, shaping its rotation and holding its structure together. Though we cannot see this substance, its gravitational influence permeates the halo, providing the unseen framework upon which the Milky Way rests. The few stars found here tend to be among the oldest known, their chemistry revealing a time before heavy elements existed in abundance. To traverse the halo is to step into a serene, ancient realm where silence stretches across unimaginable distances, and the galaxy's luminous disk appears as a thin, glowing ribbon suspended in a sea of dark. The Milky Way did not form in isolation. Instead, it grew through a long history of mergers and interactions with smaller galaxies. Over billions of years, it has absorbed dwarf galaxies, torn apart star clusters, and woven their remnants into its halo and disk. These mergers are not violent in a cinematic sense. Galaxies pass through each other with enormous grace, stars gliding past one another without collision, while gravity slowly reshapes their orbits and redistributes their gas. Even now, streams of stars from ancient mergers continue to flow around the Milky Way, like pale, ghostly rivers tracing old gravitational pathways. Future mergers will also define the galaxy's destiny. The most significant of these will be with the Andromeda Galaxy, which is moving toward us at great speed, even though the collision will not occur for another 4 billion years. When it happens, the two galaxies will dance together in a long, spiraling embrace, eventually forming a new, larger galaxy, often called Milky Way. Despite the grandeur of this cosmic event, the skies on Earth, if Earth still exists, would likely fill with spectacular vistas of merging star fields rather than chaos. Galactic mergers are the slow, majestic evolution of cosmic architecture, shaping the Milky Way into the form we know today and determining what it will become in the distant future. Beyond the farthest edges of the Milky Way lies the intergalactic medium, a realm so empty that even interstellar space seems dense by comparison. This vast expanse contains thinly dispersed hydrogen, helium, and faint traces of ionized particles, stretched across distances measured in millions of light years. If you were to drift through it, the sense of isolation would be profound. No nearby stars, no glowing nebulae, only the faint background radiation of the universe and the dim silhouettes of galaxies spread across the cosmic horizon. Yet this medium is not entirely empty. It serves as the connective tissue of the cosmos, influencing the motion of galaxies and acting as the reservoir from which new structures eventually arise. Though invisible to human eyes, the intergalactic medium plays a vital role in cosmic evolution. It carries the signatures of ancient events, including the ionization of hydrogen after the first stars formed, and the shock waves produced by galaxy clusters. Filaments of this medium form the cosmic web, the large-scale structure of the universe, which links galaxies together through gravity and unseen strands of dark matter. To imagine drifting through this space is to picture yourself in the quiet sea between islands, with the Milky Way behind you and the faint glow of other galaxies shimmering in the distance. It is a realm of profound stillness, where the scale of existence stretches far beyond the limits of ordinary thought. The Milky Way is woven with magnetic fields, subtle, invisible structures that thread through interstellar space, shaping the motion of charged particles and guiding the behavior of cosmic dust. Though these fields are incredibly weak compared to everyday magnets, their influence extends across entire spiral arms, linking regions of star formation and sculpting the flow of gas. If your eyes could perceive magnetism directly, the galaxy would appear wrapped in delicate filaments stretching from star to star, bending softly around molecular clouds and swirling near supernova remnants like strands of cosmic silk. These fields evolve slowly over millions of years, twisted by galactic rotation and amplified by turbulence in the interstellar medium. Magnetic fields also protect the galaxy's delicate ecosystems. Around stars like the Sun, magnetic activity shapes stellar winds and creates protective bubbles, heliospheres, that shield planets from harmful radiation. On larger scales, magnetic fields help regulate the collapse of gas clouds, influencing how and where new stars are born. Though silent and unseen, they are fundamental threads in the Milky Way's structure, guiding subtle processes that sustain the galaxy's long-term evolution. To acknowledge their presence is to appreciate the hidden architecture of the cosmos, where even the quietest forces play essential roles in shaping the universe we inhabit. Cosmic rays are high-energy particles that travel across the galaxy at nearly the speed of light, originating from supernova explosions, stellar winds, and sometimes even more mysterious extragalactic sources. If you could observe them with your senses, they would appear as tiny, invisible travelers passing through everything, planets, stars, and even your own body, like faint whispers from distant regions of the Milky Way. Though often portrayed as dangerous, most cosmic rays are harmless by the time they reach Earth, softened by the protective shields of our magnetic field and atmosphere. Still, they carry valuable information. Their energies, directions, and compositions act as clues about the powerful events that launch them into space. Each one is like a tiny postcard from places we can only imagine, carrying a fragment of galactic history across immense distances. For astronomers, cosmic rays function as messengers that reveal processes otherwise hidden from view. They help us understand how supernova remnants accelerate particles, how magnetic fields weave through the galaxy, and how energetic events shape the interstellar medium. As these particles move through space, they subtly alter planetary atmospheres and contribute to chemical reactions in distant worlds. Even on Earth, cosmic rays occasionally influence cloud formation or trigger rare electronic glitches in our technology. Their presence reminds us that the Milky Way is alive with motion and energy, and that even in its quietest corners, invisible travelers traverse the dark in steady, ancient streams. The Milky Way is home to an astonishing variety of planets, many unlike anything found in our own solar system. As telescopes grow more sensitive, we discover thousands of exoplanets, orbiting distant stars, gas giants, hugging their suns at blistering temperatures, rocky worlds larger than Earth, frozen spheres circling faint red dwarfs, and enigmatic ocean planets with surfaces hidden beneath layers of mist. These worlds challenge our assumptions about what a planet can be and expand our understanding of where life might arise in the galaxy. If you could drift past some of these systems, you might see rings of icy debris glowing softly, atmospheres shimmering with unfamiliar colors, or moons casting slow, graceful shadows across alien landscapes. Many of these planets reside in the habitable zones of their stars, where temperatures could allow liquid water to exist. Others survive in extreme environments, heated by tidal forces or illuminated by variable suns. Some systems contain planets locked in intricate resonant orbits, while others host lonely wanderers far from their stars. By studying these worlds, scientists piece together the story of planetary formation, how dust becomes rock, how rock becomes spheres, and how spheres develop climates, oceans, and perhaps life. The discovery of exoplanets has transformed our sense of place in the galaxy, reminding us that Earth is just one of countless worlds orbiting countless stars. The Milky Way is not merely a home to stars, but to an unimaginable diversity of planetary systems, each carrying its own possibilities. As we float deeper into our contemplative journey, a gentle question arises: could life exist elsewhere in the Milky Way? The sheer number of planets, billions upon billions, suggests that life may not be unique to Earth. Many worlds orbit within habitable zones, while others may hide subsurface oceans, kept warm by internal heat or tidal forces. Perhaps some planets host microbial life, flourishing beneath layers of ice. Perhaps others have evolved complex ecosystems beneath purple suns or red glowing skies. Even rogue planets might shelter life in deep oceans, insulated from the cold of interstellar space. The galaxy offers an extraordinary diversity of environments, each with its own potential for fostering biology. Yet, despite these possibilities, the galaxy remains quiet. We have detected no unambiguous signals, no clear signs of civilizations, only the faint natural radio emissions of stars and nebula. This silence may reflect the vast distances between worlds, the rarity of advanced life, or the briefness of technological stages. The question of whether we are alone remains open, a serene mystery stretching across thousands of light years. But in contemplating it, we realize that the search for life is also a search for understanding, an exploration of what it means to exist in a universe filled with possibility. The Milky Way holds answers we have not yet learned to perceive, and part of our journey is the quiet appreciation of that cosmic uncertainty. The Milky Way, though ancient, continues to evolve, Its stars orbit in complex shifting patterns. Its spiral arms slowly reshape themselves, and new stars continue to form from interstellar gas. Over billions of years, some regions of the galaxy will quiet as their gas is consumed, while others may briefly brighten with bursts of star formation triggered by gravitational interactions. The most dramatic event in our galaxy's future will be the long-anticipated merger with the Andromeda Galaxy. Though it sounds catastrophic, the event will unfold over billions of years, with stars passing each other harmlessly as the two galaxies blend into a new structure. From within, the night sky would transform into a breathtaking display of merging star fields and luminous arcs stretching across the horizon. Eventually, the combined galaxies will settle into a massive elliptical form, their gas reservoirs depleted in star formation, slowing. The Milky Way we know will no longer exist, but its stars, including our sun's distant remnants, will continue orbiting within the new structure. The galaxy's future is a story of transformation rather than destruction, a demonstration of cosmic time unfolding at scales beyond human experience. As we imagine this distant era, we sense the continuity of the cosmos. Galaxies merge, stars evolve, and matter cycles endlessly from one form to another. Nothing is lost, only rearranged, and the universe moves forward in quiet, majestic rhythm. As our journey through the Milky Way draws to a gentle close, imagine yourself drifting outward from the bright galactic center, passing through star-rich regions, through spiraling arms, and into the quieter outskirts where our sun resides. The stars begin to thin, the nebulae fade into distant clouds, and the luminous disk becomes a sweeping river of light far below. This return is not a retreat, but a homecoming, a soft reawakening to the familiar region of the Orion Arm, where Earth orbits quietly within the local bubble. The vastness you have explored remains within you, not as a burden, but as a calming perspective. You have traveled across ancient stellar populations, newborn suns, wandering planets, and cosmic mysteries that stretch the imagination. As the galaxy settles around you once more, the Milky Way becomes less an object of study and more a companion, a luminous cradle in which all our stories unfold. You have drifted across tens of thousands of light years in thought, carried by curiosity and quiet wonder, and now return with the serene knowledge that home is part of something immeasurably vast. The journey invites you to breathe deeply, to feel your place within the cosmic rhythm, and to rest in the gentle truth that the universe is both immense and intimately connected to the small world where you now lie. Beneath the graceful spiral of the Milky Way lies a subtle tapestry of structures, invisible to the naked eye. Long streams of stars stretching across the halo, remnants of ancient dwarf galaxies, shredded by tidal forces over billions of years. If you could see them directly, they would appear as faint rivers of starlight drifting in arcs around the galaxy, each one a thread of history unraveling slowly through the darkness. These stellar streams are the fossilized echoes of cosmic encounters, revealing how the Milky Way grew, not by sudden violence, but by gentle absorption of smaller companions. Observing them is like reading the wrinkles in an old tree, each line a memory of past interactions. Some streams originate from clusters, others from dwarf galaxies, such as the Sagittarius dwarf, still in the process of merging with us. These structures form the quiet, ghostly scaffolding that surrounds the galaxy, shaping its gravitational field in ways we are only beginning to understand. As our instruments become more precise, a hidden architecture emerges, a halo woven with shells, tendrils, and arcs, each marking the path of a long-lost stellar community. These remnants tell a story of continual renewal, galaxies merging, stars migrating, and orbits shifting in majestic slow motion. By studying them, astronomers can reconstruct the Milky Way's family tree, tracing back billions of years to discover how our galaxy came to be. Imagine drifting along one of these streams, surrounded by stars that once belonged to a completely different galaxy. Their light would carry the chemistry of their origins, different from the stars of the Milky Way's disk, whispering tales of ancient journeys. These faint structures remind us that the galaxy is not static. It is an evolving organism, gathering memories of every encounter and weaving them into its vast and luminous form. Hypervelocity stars are rare and extraordinary travelers, stars moving so fast that they can eventually escape the Milky Way entirely. Many are thought to be flung outward from the galactic center when binary systems wander too close to Sagittarius A*, the supermassive black hole. One star may be consumed or captured, while the other is launched outward at unimaginable speeds, becoming a runaway streaking across the halo. If you could follow one of these stars, you would witness a solitary beacon hurtling through emptiness, leaving behind everything it once knew. These stars carry with them the fingerprints of their violent departure, their trajectories acting as clues to the gravitational processes near the galactic core. Others may be propelled by supernova explosions or interactions with dense star clusters, each mechanism creating a cosmic wanderer destined for intergalactic space. Hypervelocity stars are remarkable not only for their speed, but for the perspective they offer. Their motion reveals the shape of the galaxy's gravitational field and the distribution of dark matter extending far beyond the visible disk. Some of these stars may eventually drift into the void between galaxies, destined to shine alone for billions of years, with no companions except the faint background glow of the universe. Their journey is both dramatic and peaceful, a testament to the extraordinary forces that occasionally disrupt the calm of cosmic order. To imagine traveling alongside one is to envision a perpetual departure, leaving the Milky Way behind, watching its luminous disk shrink into a distant band of light, and finally becoming a lone voyager in the quiet sea of intergalactic darkness. The earliest stars in the Milky Way formed from pristine hydrogen and helium, left over from the Big Bang, devoid of heavier elements. Their lives were short and spectacular, ending in cataclysmic explosions that seeded the galaxy with carbon, oxygen, nitrogen, and the metals necessary for planets and life. Over billions of years, each generation of stars enriched the interstellar medium further, slowly transforming the galaxy from a simple elemental structure into a place capable of producing worlds like Earth. This gradual enrichment is known as chemical evolution, a slow alchemy unfolding on a galactic scale. With every supernova and stellar wind, the Milky Way learned to build complexity, creating clouds rich enough to form rocky planets, oceans, atmospheres, and biological chemistry. The pattern is cyclical and poetic. Stars create elements, elements form planets, planets give rise to life, and life reflects back on the stars that made it possible. As you drift through the galaxy with this understanding, each nebula becomes a treasury of potential, each star a factory shaping the chemistry of tomorrow. Even now, new generations of stars are being born from material enriched by countless ancestral suns. The Milky Way is not merely a collection of stars, but a cosmic crucible that continually transforms itself. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were forged in stars long before the sun existed. In this sense, chemical evolution is not just a scientific process, but a story of inheritance, connection, and cosmic continuity. It reminds us that we are literally made of the galaxy's past, and that all future life will emerge from the elements being created today. The Milky Way is alive in a chemical sense, learning, enriching, and evolving with every passing epoch. If you could watch the Milky Way from above, over the course of hundreds of millions of years, you would see a stunning slow-motion ballet, stars drifting in graceful arcs, spiral arms forming and dissolving, clouds collapsing into new suns, and the galactic bar rotating like a luminous spine. Galactic rotation is not uniform. Stars closer to the center orbit faster, while those farther out move more slowly, though not as slowly as they should. according to visible matter alone, one of the earliest clues pointing to the existence of dark matter. Despite this complexity, the overall structure of the galaxy remains coherent, sustained by the interplay of gravity, motion, and time. It is a grand symphony with no conductor, regulated only by natural forces acting across scales too vast for human experience. Each star contributes its own note, its own orbit, creating a pattern that is both dynamic and enduring. As you imagine drifting above the disk, the galaxy becomes a living organism, rotating with serene purpose. Spiral arms act as density waves, guiding stars into patterns. The bar channels material toward the center, feeding slow growth of the core, and the halo surrounds everything with a vast gravitational cushion. The rotation takes so long, hundreds of millions of years for a single orbit, that even civilizations would rise and fall before a star completes its journey around the center. Yet the motion is steady and continuous, a rhythm as ancient as the galaxy itself. To contemplate this rotation is to appreciate the Milky Way, not as a static snapshot, but as an ever-turning wheel of time, carrying worlds, stars, and cosmic histories around in a perpetual tranquil dance. As our expanded journey reaches its final stretch, we step outside the Milky Way entirely to view it from the vast arena of the universe. From this perspective, our galaxy becomes a single shining island among trillions, each one a world unto itself, with stars, planets, mysteries, and histories. The Milky Way belongs to a small collection of galaxies called the Local Group, which includes Andromeda, the Triangulum Galaxy, and dozens of dwarf companions orbiting like tiny satellites. Beyond this group lies the Laniakea supercluster, a colossal gravitational basin containing hundreds of thousands of galaxies flowing together toward an enigmatic region known as the Great Attractor. Seen from here, the Milky Way is just one luminous thread woven into the cosmic web, a vast network of filaments and voids stretching across the observable universe. This broader view places our entire journey into perspective. All the stars we have visited, all the nebulae, planets, and ancient remnants exist within a single galaxy that itself is merely one small piece of the universe's architecture. Yet within this small piece, life arose, consciousness bloomed, and human beings learned to look upward with curiosity and wonder. The Milky Way is our home, not because it is uniquely special, but because it is the cradle that shaped our atoms, our world, and our story. To drift beyond it in imagination is to see the beauty of everything we have explored, not diminished, but contextualized within a universe far larger than our greatest dreams. And as you return gently to your place within the galaxy, you carry with you the quiet understanding that home is vast, ancient, and beautifully interconnected. Thank you for joining this long, peaceful voyage through our galactic home. Your presence, your curiosity, and your willingness to embrace this meditative exploration give life to these journeys. Each listener becomes part of a growing constellation of dreamers who find comfort in science told softly, who appreciate the merging of knowledge and tranquility, and who help illuminate the path forward for this channel. Your support, whether through listening, subscribing, or simply returning for another night's story, means more than words can express. As we move toward our first 1,000 subscribers, your companionship helps these quiet narratives continue to bloom. Every person who joins adds another point of light to our small digital sky, creating a community bound by wonder and serenity. Thank you for being here, for listening, and for allowing this story to drift with you into the gentle spaces of rest. And now, as the final echoes of our galactic journey fade, let your mind settle like stardust returning to calm. The Milky Way stretches quietly overhead, no longer a distant mystery, but a familiar river of light you have sailed from end to end. Feel the slow rhythm of the galaxy, matching your breath, the steady pulse of cosmic time guiding you toward rest. The universe does not rush, and tonight, neither do you. You drift within its vast arms, safe, weightless, and unhurried. Our journey comes to rest as the stars dim gently behind your closed eyes. The galaxy sleeps, and you drift with it, carried by the quiet majesty of everything you have seen. Let the calm of 100 billion suns soothe you. Let the silence of interstellar space wrap around you and allow yourself to fall softly into sleep. The cosmos is wide, the night is peaceful, and you are home.